Today I'll be showing you the new features that are part of the recent 2017.3 release for geophysics. If you have any questions during the webinar, please type them in using the question box in the chat window, and I'll get to them at the end of the session. Now, before I get into the features of 2017.3, let me give you a brief summary, quick summary of what GVERSE Geophysics is. From our 2017.2 release in the spring of this year, Size Vision has been rebranded and is now known as GVERSE Geophysics. So GVERSE Geophysics is now the seismic interpretation package in geographics. You have access to all the existing workflows, and we're fully backward compatible, so there is no chance of you losing any of your existing work. But we've introduced a lot of new features with 17.2, and the main feature that we introduced with the rebranding was our new 3D visualization and interpretation environment. With the 2017.3 release, we've made a lot of improvements in both our legacy interface and our 3D viewer, and one of the major themes for us this release was better integration. So now, from directly within the 3D view, you can create cross-sections and seismic backdrops in GVERSE Geomodeling and Smart Section. We've also added the ability to select a well and open it in any of the well applications in geographics directly from the 3D view. We've also worked on sending sections to and from the 3D view to our seismic section viewer, or what you may call the 3D viewer for seismic. Then we've tried to ensure that all the trace scaling and color palette options are available in both those views. This ensures that whether you're looking at a section in 3D or in 2D, they're represented in exactly the same way. We've also added new tools and improved existing ones for a better interpretation experience. We have a new 2D picker that relies on correlation and is very useful when picking through noisy data and across faults. It works by computing the correlation across multiple paths and then choosing the one with the most correlation, and I will talk more about this later. We've also improved our horizon snapping ability so that you can snap an entire horizon to the nearest event or the first event above or below existing picks. You can now flatten the entire 3D scene along the horizon to get better idea of your stratigraphic features. We've updated the undo redo functionality of our horizon and faults, so we've reworked it, and now we maintain an independent history for each horizon and fault. The undo and redo actions are now context aware and apply only to the active horizon or the active fault. When you switch active horizons or active faults, the history associated with the new active horizon is the one that is used when performing an undo or a redo. And I will show you how this works in a bit as well. We also have a new variable color density plot to display synthetics along your well bores, so you can now match your color palettes and make a visual comparison of your seismic and your synthetic more easily. We're also constantly working on our 3D engine to make it more capable. With 2017.3, we can now view mapping grids and horizon picks associated with those mapping grids in the 3D scene. In other improvements to the engine, we've added the capability to draw GeoAtlas layers directly on your horizon surface. So you can take your culture layers or a contour layer or basically any GeoAtlas layer and draw it right on top of the horizon surface. Finally, in every release, we always have some usability enhancements that are aimed at making your workflows more efficient. And in this release, we've added new toolbars for the scenes to enable better multi-screen usage. We have hotkeys for outlines and probe navigation and a bunch of other enhancements. The most important of these, though, is the consolidation of all our depth conversion settings into a single dialog. These were spread out all through the application. We've taken them all and put them at the same place so that you can access them more quickly without having to dig through various menus. We've also added a depth conversion tab in the 3D view ribbon, so you can access your depth conversion workflows directly from the 3D view without having to switch back and forth between the two interfaces. So these are the things that are all part of the 2017.3 release, and I'm now going to demonstrate some of these workflows so that you can see these features in action. So let's start with the integration stuff first. From the 3D view, I can just right-click on any section now and open it as a seismic backdrop in a Smart Section or GVERSE Geomodeling. That's going to use the active velocity model, convert the section to depth, and open it in your geomodeling interpretation. Same thing for wells. I can select a well, right-click here, and just open that well in WellBase, Prism, or LogM, or any of the other geographics applications for wells. This saves me a lot of time or a lot of hassle when trying to find the well on your map and then opening it in the required application. So you can now do this directly from the 3D. Within the GVERSE Geophysics application, if you have a section open in 3D and you want to view this in the 2D seismic viewer, that's just a click away now. So just right click on the section, say view in 2D, and that's going to open it as vertical section, vertical seismic display in your in your 2D view. The color palette, version information, everything else is preserved, and you can work with this section in a 2D environment, which is something a lot of people still prefer. The reverse also works. So if you're looking at a section in 2D and you want to now look at in 3D, you can right click here and say view in 3D, and that's going to open it in whatever tab you select here. So I have like 6 3D views open. I can choose any of these, right click here, say view in 3D, and that's going to open that in the relevant tab in my 3D view. Now I can look at that section in a 3D view, that exact same orb line in the 3D view. If you want to send multiple sections to the 3D view, you can use this dialog up here in the ribbon that lists down all of the sections that you have open. You can select the ones you want to view in whichever 3D tab that you want. You can also choose to send your horizons and faults into the 3D view so that you don't have to go back to the interpretation tree and then or the 3D view ribbon and add them to your scene. So you can do that directly using this dialog. Finally, we've added trace scaling support in the 3D view as well. We have 3 modes. They're up here in the color palette box of the ribbon: the interpretation mode, survey mode, and section mode. Section mode is the one that we use by default, and these modes basically define my color range. So when I have the section option selected, I look at the data on my entire section, in this case this orb line, and figure out the min and max value and apply that to my color palette. And you can see that range given here in these edit boxes, again in the color palette box of the 3D view tab. But because this is limiting itself, the section mode is limiting itself to the section only, if I open another section, so if I open, right click here, and let me just switch to section mode, right click here and open a cross line rather. When I select this cross line, you can see that this range is slightly different than the range for the orb line. That's because both of these are in section mode right now, and they're just looking at the values on the section and computing a min and max range for that. Now the sections that I have open are close enough in values so that there's not really a big difference between the colors that are representing these amplitudes. But if one of these had an outlier, there's a chance that these could be drastically different, and then my colors would not actually match at these intersection points. That is where the survey option becomes useful. So if I switch this to survey mode, switch both of these to survey mode rather, now the min and max, if you can see these boxes here, these are read from the entire cube of data, right? So the survey mode looks at the entire data range for your cube, figures out the min and max value, and uses that for your color palette. This value will always be the same for each section with the same data version, so the color will always mean the same thing, and you will get a perfect match at your intersections. The interpretation mode, which is the third mode, takes this concept of the survey and extends it to the entire interpretation. This will read the min and max value for all surveys, including any 2D lines that you have in your entire interpretation, and assign the colors based on this value. And this is useful when you're trying to work with data across surveys, trying to match your 3D and 2D lines and stuff like that. The 2D viewer, our vertical seismic viewer, always had these options in their just seismic display window. We always had the interpretation and the survey option. But from 2017.3, we've also added the section constant option, which limits the data range for your color palette to the section only. Finally, we've added support for the PAL-X format in the legacy interface as well. So your 2D viewers, your main map view now support PAL-X format. The PAL-X format can store transparency information. That is the only difference it has from the traditional PAL format. And now you can use these color palettes in the 2D view as well. So whether, if you have a PAL-X palette applied in 3D, you apply the same PAL-X palette now in the 2D view and your map views as well. Okay, so now I'm going to shift gears a little bit. I'm going to shift gears a little bit and show you some of the interpretation capabilities that we've added in 2017.3. Like I said earlier, we have a new auto picker, and it works by computing correlations along multiple paths in the area of interest, and then chooses the path with the best correlation. In the Horizons tab, because this is more of a tracker, it lives in this drop down with the rest of our trackers. It's called the segment pick mode. You can click here, and then you have to define a start point and an end point. Let's say you want to pick this interface across these faults. Define a start point, give it an endpoint, double click here to commit, and it's going to now track that that event fairly accurately. So when I pick a start point and an end point, the algorithm defines an area using a window height parameter that is available in my pick parameters and compute all possible paths from the start point to the end point within that window. Then it computes the correlation along these paths and finally draws my horizon picks along the path with the highest correlation. So it's not just doing correlation from one trace to the other, it's actually doing a correlation along the path, along the entire path, and finding the maximum correlation and along that path, and then choosing the path with the most correlation. And as you can see, it works really well across faults and through nodes. Now, staying with horizon picking, I want to show you the new undo redo functionality as well. All the picks that I make are available in the new undo and redo dropdowns. Here, these lists are updated as I make or edit my picks. So if I open a crossline here, let's say crossline 1138, and switch to the 2D pick mode and pick this interface, that's going to update here as well. Let's erase a few picks. So I have a lot of different erase modes as well. Let's erase these picks, maybe run the correlation tracker. That's going to create a surface for us here. I can also do a surface erase, which lets me interact directly with my surface. So I can just sort of interact directly with the surface, remove some picks here. Now, all of these actions are available as under my undo menu. So I removed some picks on the sample 3 survey. I correlated my picks. I removed picks on the cross line, marked picks on the cross line, all of that. So I can undo these removed picks. That's going to bring these picks back again. I can undo my correlation. That's going to get rid of my correlation. Of course, anything I undo, I can always redo from the redo list, and that's going to do my correlation again. Now, that did not run the entire correlation algorithm again. It just undid that action, and so I already had that information, and I just now make it a part of the horizon again. And the way we've reworked our undo and redo functionality is that if you switch your horizon, so let's say I want to now pick horizon H2, and I pick this interface here, and maybe mark it here. Now the undo list is now giving me all of the actions that I did for my horizon H2. That's these 3 actions. I mark picks twice on an inline and then on a crossline. I can undo and redo these actions as well. But I switch back to H1 as my active horizon, and now the undo and redo lists switch also to H1. And this also applies to faults. So if I have a fault that I'm making adjustments in, the undo and redo functionality will apply to that fault only. So if I can go in here and I can edit this fault, maybe you can see that you get this undo, the segment modified on inline 545 undo action here, which I can go in and undo. When I'm in the horizon menu, all of my undo and redo actions are from my horizon. So our horizon undo and redo are now context aware and apply only to the active horizon and maintain a list for each horizon and each fault. Next, we have horizon snapping. We've updated our horizon snapping workflow. Let me switch to the 2D window. I have a window here with a horizon that I want to snap. All right, so let's say I want to take this horizon and I want to snap it to another event. The snapping operation can let you do that. It's accessed from the horizon operations, and go to snap operation, choose the horizon you want to snap. Let's say I want to do the horizon H3. And now I have this, obviously I can snap it to the nearest peak here, or the first peak up or down. Before 2017.3, the snapping window always centered on your existing pick. So even if I use the up option, the window would still be centered on my existing pick, which meant the up option didn't really always work as desired. Up and down options, they kind of work more like the nearest option. So we fixed that now in the sense that now the window moves. If you have the up option selected, the window is going to be sitting above your picks. It's going to exclude the pick that you've already made, and it's going to be sitting above those picks. And with this offset option, which I've set to 30, so if I want to take these picks, horizon H3, and I want to snap them to this event, which is the one above this first peak that I have, I can set the window, the offset window, so that my window starts above this event. So that's about 30 samples. I've set it to 30 samples. Now when I snap, instead of finding the first peak, because my window started here, it goes to the second peak and snaps there. So that's how we've made the whole horizon snapping functionality a lot more flexible, gives you a lot more control over where you want your horizon picks to jump. We also have now the ability to take the entire 3D scene and flatten it. So any horizon that you have in your scene, you can right click here on that horizon, say flatten, and that's going to flatten your scene as per that horizon. You can see that horizon is now a flat line, and the rest of the seismic sort of adjusts itself to show you what it would look like if that horizon was flat. If your horizon surface is displayed, they're forced into intersection mode. This helps us save computation time by not having to flatten the entire horizon surface, but you still get an idea of what your horizons are doing relative to the flattened data, because the intersections you see here are all flattened relative to the selected horizon. To unflatten, just go to your 3D view tab here in the ribbon, toggle off the flatten switch, and that's going to restore your view to the unflattened state. Another feature that we've added is another way to view your synthetic seismograms. So let me switch views here. In 2017.2, the only way you could view a synthetic along a well was in this wiggle form. We draw this wiggle, and then that's a fairly good way to view your synthetic and sort of figure out if it ties well with your seismic or not. But now in 17.3, we've added another mode which you can access from your display settings. In the log curve section, configure for your synthetic trace. We call it the panel mode. It's basically a variable color density display for your synthetic. If I switch to the panel mode, I can choose a color palette so that it matches with my seismic. I can define the range as well, so I know that the section I have displayed back here is around plus minus 6,600. I can set that here, and now I can see, in the variable color density display, how my synthetic matches with my seismic. I can see the match. I can sort of move this up and down and take a look at what my synthetic is doing relative to my seismic. We've also added support for viewing your mapping grids in the 3D environment. To create a mapping grid is basically if you want to grid your horizon. So let me go to my main map view. I have a horizon here that I've picked along these 2D lines. If you want to take this horizon and grid it in a specific area, you create a mapping grid. So let's just create a mapping grid here, draw this polygon shape, double click to commit. I can give the grid interval, select the gridding method, click OK. It's going to create a mapping grid here and then grid that horizon on here. So now from 2017.3, of course you could always do this in the legacy interface. You could create mapping grids, you could grid horizons, but we had no way of viewing them in the 3D environment. And in 2017.3, we can actually now do that. So from the mapping grid I just created comes up in the interpretation tree here. The interpretation tree contains everything that is part of your interpretation, including your horizons, your faults, seismic surveys, and mapping grids now. So I can click the plus icon. That's going to add the mapping grid to my 3D scene. But when you add a mapping grid, that's basically just the extents of the mapping grid with the individual cells given in this grid form. To view the gridded horizon, you're going to have to add that horizon to the scene. So again, from the interpretation tree, I add my horizon in here. That adds the horizon here. By default, it adds just the 2D components. So you can see your 2D components here. Let me just hide this mapping grid so you can get a better view. You can see these 2D components here. But from my display settings for the horizon, I can turn on the mapping grid component as well. So that's now going to show me the gridded surface as well. Let's turn off the 2D lines because they're sort of overlying on here the grid surface, and now I just look at whatever the grid that I had or the horizon values that I created. If I turn on my mapping grid, now I can see the extents of my grid plus the resolution of my gridding of my features, because I can see the individual cell size as well. Finally, we now have support for GeoAtlas. Take any GeoAtlas layer and drape it right on top of the horizon. You do that from the display settings for the horizon. Again, we have this new option called drape layer. Check that on. Bring up the select layer dialog from, this is the same dialog that's used across geographics. You can choose the layer that you want. I have this layer, 2D line layer that I created. I'm just going to draw that on my horizon. And that's now going to draw that layer right on top of my horizon. Also, that's a new feature. You could add you could add GeoLattice layers in the 3D view in 2017.2, but starting 2017.3, you can actually draw it right on top of your horizon. And this could be any layer. Of course, this could be your culture layer. This could be a contour layer, or or it could be a combination of layers, and it draws it right on top of the horizon. Right, so, and finally we have a lot of usability enhancements. Like every release that we add, the first of these is this scene toolbar that we have up here. If you hover on these two arrows, it sort of shows itself, and if you click it, it's going to write itself on the scene. The good thing about this toolbar is that if you take this window out and maybe move it to another screen, the toolbar goes with it along with the sidebar, and that helps you sort of not have to switch, because the ribbon still is in the main application window, and if you wanted to add an inline, you'd have to sort of minimize this, go to the ribbon and add that inline. But with this toolbar, you can just choose those modes here directly, add a cross line, add a probe, horizon, surfaces. So it makes it a little easier to use, especially in a multi-screen environment. We've also added navigation options for arb lines. You can now take your arb line and move it incrementally. The right and left arrow keys will move it in the inline direction, and the up and down arrow keys will move it in the crossline direction. So you can now increment or move through your arb lines in inline and crossline increments. We've also added support in 2017.3 to actually take these arb line nodes and modify the arb line using your mouse. Just hold the shift key down and put it at a new location, and that's going to redraw your arb line at that new location. So we also added that functionality. We also have these hotkeys for probes. So if I show this probe here, to move this probe using my arrow keys, I can use the right and left arrow keys to move the inline faces outwards. If I hold the shift key down and use those same right and left arrow keys, the inline faces will move inwards. Use the control key and the right and left arrows to move your crossline faces outwards. Combine the control and the shift key and the arrow keys will move the crossline faces inwards. The up key will move the top face of the probe upwards. The down key will move the bottom face of the probe downwards. Again, use the shift key, and the down key will move the bottom face upwards, and the up key and the shift key together with the shift key will move the top face downwards. Then for our well display, we've added these symbols that are read directly from the database and displayed in, before 2017.3. These were just generic symbols for all wells, but now these symbols actually reflect the status of your well. These can be set up in Wellbase. We're reading them directly from the well symbol manager in Wellbase based on the status field for your well as defined in Wellbase. We've also made the selective transparency tool a little easier to use. So selective transparency basically lets you make a select range of amplitudes transparent. So for example, if you just want to look at your very low, very high negative amplitudes, you can draw a line along the histogram that's going to hide or make all of the other colors transparent. We made that workflow a little easier by introducing this toolbar. So now the same thing, instead of drawing along the horizon, you can just toggle this button on and then adjust the threshold directly on the histogram using the control key and drag with the mouse to achieve the same results. And finally, we have a new depth conversion tab in the 3D view interface, which lets you, if you want to create a velocity model or change your active velocity model, create a velocity cube or a depth volume, you can do that directly from the 3D view without having to switch back to the legacy interface. We've also updated the settings for our depth conversion. Now they're all found at the same place. So if you want to define the method to display your wells in the 3D view and your vertical seismic, so if you want to use the velocity model or you want to use your velocity surveys or set up reference wells, you can do that here. And at the same place, you can define the method you want to use for your horizon display or your horizon conversions. If you want to grid velocities on horizons, grid depths on the horizons, you can choose from a variety of methods here, and also the active velocity model, or get velocities along the horizon directly from the active velocity model. These used to be spread out all over the application. We've sort of brought them together, and of course these are not, you don't have to come to the 3D view to access these. These are also available in the depth conversion menu. All of these options, including the new settings menu, settings dialog, which lets you set those same things here. Right, so that's basically what we have for you in 2017.3. We've focused on integration. We've focused on enhancing the interpretation capabilities with the new auto picker, with the horizon snapping operations, flattening your 3D scene, adding mapping grid support. So we've worked on visualization as well, and of course we've added some usability enhancements that we have we think will make your workflows a lot more efficient. So that's it from me, guys. Thank you for attending, and do feel free to reach out to us and contact us if you do think of any questions, or if you have any general feedback. I encourage you guys to update to 2017.3 so you can try these things out. A lot of these features that we've added are based on user feedback from users like yourselves. So we'd appreciate if you can reach out and tell us what you like, what you don't like, what you want to see, and hopefully we can make it a part of our future releases. So thank you very much, guys. I hope you enjoyed this webinar, and until next time.